Hello, welcome to Chapter 11, Hypothesis Tests for Two Populations. In particular, 11.1, Hypothesis Tests for the Difference Between Two Means, and we're back to independent samples. So let's walk through the 5 suggested steps from hypothesis testing to see what is new and different in this section, and then we'll do some examples. So starting off with hypotheses, we still have HO, the null, and H1, the alternative. And now, for means in particular, we'll have, because we have 2 population means we're looking at, we're going to have mu1 equal to mu2 as our null hypothesis. And you'll see in some books, this could be written as mu1 minus mu2 is equal to 0, having everything on one side. That's closer to our work in chapter 10 with the with the confidence intervals. However, writing it as I did first, mu1 equal to mu2, that's going to make more sense for the calculator work. So I'll probably stick with this version, but know that if you like the other version, you're welcome to do that. And you'll see videos online if you go search for them that way. And so then the alternative, you might be able to guess, it's going to be that mu1 is not equal to mu2, or it could be that mu1 is less than mu2, or it could be that mu1 is greater than mu2. So there's those same 3 cases of not equal to, less than, and then greater than that we saw in chapter 9. And we have the same idea as before also, where a not equal to symbol leads us to a two-tailed test, a less than symbol, kind of depending on how you set it up, but generally a less than symbol, if that's what you put into the calculator, that's going to be a left tail test, and then a greater than symbol means a right-tailed test for our critical value work. So that's pretty much the same as before. The distribution here in this chapter, like we did in chapter 10, we jump right past looking at means when sigma is known, and we're going to have instead 2 means. And it might be sort of important to notice that chapter 9 was 1 mean, now chapter 11 is 2 means, because in fact, we will finish the semester with 3 or more means, and it's going to be something different. So it's kind of important to note what kind of a situation you are in. And we are in 2 means. Generally, sigma is going to be unknown. So not too surprisingly, we do use the t-distribution. And we'll use the inverse t function on the calculator or the t-table for critical values. 1 or 2 critical values, depending. And then, like in chapter 10, the degrees of freedom, df, is going to be the smaller of n1 minus 1 and n2 minus 1, the smaller of those 2 numbers. That's the simple way. If you want to, if you're a perfectionist, and I sort of am, so I get it, if you want to use the result from the calculator in step 3, the step below, the calculation step, if you want to go and use that number and then after that get your critical value, so maybe not do your critical value in step 2, that's okay. You'll almost always get the same conclusion, but every now and then the more accurate version, which is the one from the calculator, will give you a different answer. But truly, truly, truly is accepted. It's printed in our book that you can just choose to use the smaller of the 2 individual degrees of freedom. All right, continuing on. Then we've got the calculations from the calculator. And so we're going to sample or lists. We're going to have either our sample information or the lists. So that's the same. We're going to use toSamp t test. All right, so important that now you get to be in the test area. Chapters 8 and 10 were intervals, right? So now we're in tests. You will have that same question about pooled, and it's the same thing. We're generally going to answer no. And basically that's your default, unless you're told that the unknown sigmas are equal to each other. I'll write all that out. So you just leave it on no, unless, as I say here, it's the default, unless told that the unknown sigma 1 and sigma 2 are equal to each other. It could be that there's reason to believe that, but we aren't going to deal with that. All right, and then we get out of this the test statistic, which you are going to continue to label very, very clearly. Use your words, test statistic T, and then the p-value. And then plus the degrees of freedom if you want to use it. There's no pressure to use that value. And in fact, I don't think that our book does in the back of it. So let me write that as and. And so we'll see that when we get to the calculator. All right, the comparison is the same. So just as a reminder, because we've been off doing confidence interval. So one comparison, is using the test statistic and the critical value. Right, two numbers on the horizontal axis, and that's where we have our picture. And I'll maybe just draw a right-tailed test. So wherever your critical value is, right, some sort of critical value, and then that creates a reject the null zone. And then where's the test statistic? You'll see where it lands in relation to that. So this is just an arbitrary picture here. And then or there's still going to be that extra credit option for the final exam. You can also compare the p-value to alpha, which is the significance level. So if you got that in chapter 9, yay, because that's still all going to be true. And we have that same little poem. If the p-value is low, the null must go. So the p-value, if that's less than alpha, then we reject the null. Otherwise, we fail to reject the null. All right, so a lot of that will seem familiar. And then for the final conclusion also, for sure, you're either going to write down, reject the null and be complete. It's rejecting the null, not just reject. Or you're going to fail to reject the null. Oops. So you got to write that out. And then the other part of the conclusion is to make a statement about supporting the alternative or not, using whatever wording is in the problem. So make a statement about supporting the alternative, H1, or not. Get some sort of wording from the problem. All right, so looking at the time, I think I will wrap up this video and we'll do a couple of examples in part 2.